Hello everyone, welcome to Teaching Math. Today you're going to learn how to simplify numbers with zero and negative exponents. You'll learn why a number to zero power equals 1 and how negative exponents represent fractions, numbers less than 1, not negative numbers. It's another way negative exponents help us show very small numbers. Let's get started. This might be very confusing for some students, but once I explain it, it will be easy. Anything that is raised to the zero power equals 1 as long as it is not a zero, number 0, okay? And negative exponents means it's a fraction or it's closely related to decimals, numbers with decimals. Obviously, fractions are decimals. Example 1, 7 raised to the 0 power. Okay, so how do we get there? We already know that when we have a number, let's say 7, and when it doesn't have any exponent, we know that it's exponent of 1. And then if we divide by 7, it will be exponent of 1. What is 7 divided by 7? We know it will equal 1. And if we follow the exponent rule, we know we have to subtract the exponents, right? And that will equal 7 raised to the 0 power. It's that simple, okay? It's that simple. Let's go ahead and do a few examples. So let's say if I say a raised to the 0 power, even though we don't know what a is, we know for sure it's going to equal 1, right? And what if I say, here's the confusing part, 2a raised to the 0 power. Now here's the important part. When we talk about the exponents that are next to a number or a variable, that's where they belong. So these two are separate. So if you were thinking, right, this equals 1, there could be an error because a raised to the 0 power is 1, but 2 is raised to the first power. So that will be 2 times 1, and that will equal 2. That's a confusing one. It's a tricky one, so make sure you know that part. So 5 raised to the 0 power, you guessed it, 1. X raised to the 0 power, 1. 5x raised to the 0 power will be 5, okay? Because it's 5 times 1. All right, now that we understand the 0 power and where it comes from, let's go ahead and understand what is an exponent with a negative power. Okay. A raised to the negative n power. It says that the rule is it's 1 over an, but how do we get there? So let's start with 7 that was raised to the 0 power equals 1. So if I go ahead and from here go down to, well, we start 7 raised to the first power equals 7, right? And then go down to, like, let's do division, right? So if we're dividing, then we're going to go backwards to negative 1. So if 7 raised to the 0 power is 1, that means 7 raised with a negative 1 power, it will be 1 over 7. Okay? And then if we go ahead and do 7 raised to the negative 2 power, it will be 1 over 7 to the second power. Okay, that's where it's coming from. Okay, so one thing that students do most often, they rewrite this as 1 raised to the 7th power, and then they write negative 2. Well, we already simplified, right, the negative exponent, rewriting it as a fraction. So when you're doing that, you're writing fraction of a fraction. Here, I'm going to expand this for you so you can understand that is incorrect, right? It's not going to happen. So if I say 1 divide 7 raised to the negative 2 power, this means 1 divide by 1 divide by 7 to the second power. I can rewrite it so you can understand it better. And then in division, we do keep it, change it, and flip it. And you can see that will be 7 to the second power. So this is not the same as 7 raised to the negative 2 power. So make sure you don't make that error. This part was a bit confusing. Don't worry about it. Just as long as you remember that you're not going to write negative 2 when you're simplifying. You're writing 2, not negative 2. You'll be fine. Let's go ahead and do another example. Take this down. Okay, our second example here, it says x has a negative third power raised to the negative third power. We already discussed that it's 1 over x to the third power, not negative third power. Okay, and then I'm going to do one more with y raised to the negative 2 power will be 1 over y and 2, not negative 2. Similarly, when we have 1 over m raised to the third power, we can rewrite it as a negative exponent by m negative 3 power, and n, right, raised to the 6th power means that is n raised to the negative 6th power. So we can go back and forth if you want to. So now let's pay attention to this one. This is a tricky one, and I want you to know because you will come across a lot often. So 2 raised to the 5th power divided by 2 raised to the 7th power. We know from our division rule that we're going to subtract the exponents. 2 raised to the 5th power minus 7. This will equal 2 raised to the negative 2 power. But again, our rule is we're not going to leave it as a negative exponent, and we know negative exponents are fractions. I'm going to rewrite it as 1 over 2 raised to the 2nd power. You can also evaluate this and write 1 over 2 times 2 is 4. Okay, that was a tricky one, and make sure you pay attention to that and make sure you finish it with a positive exponent, and if it's a number, you can evaluate if it's not a big number. Here's one example just for you. Go ahead and try it. Maybe I should include 1 or 2. All right, let's go ahead and write a raised to the 2nd power divided by a raised to the 5th power. What does that equal? And 6 raised to the negative 2 power. What does that equal? Pause the video and try on your own. Okay, let's go ahead and do this again. We know the division rule is that we will be subtracting the exponents. So a raised to the 2nd power minus 5 will equal a raised to the negative 3rd power. And this will equal 1 over a to the 3rd power. And the second one, we will write 1 over 6 raised to the 2nd power. Or we can write 1 over, what is 6 times 6? 36. Wow, nice job. You just learned one of the most useful exponent shortcuts. Next time, we'll combine all these skills to simplify monomials using multiple exponent rules together. If you're learning something new here, don't forget to like and subscribe to Teaching Math. And remember, learning math takes patience, practice, and perseverance. See you next time.